Welcome to Joystick. In this video, we'll solve together the best time to buy and sell stocks number 2 problem from Leetcode. I have already created a video on the first version of this problem, which you can find in the top right corner of the video. We are going to solve the second version of this problem in this video. So let's begin by checking out its problem statement first. You are given an array of prices. These are the prices of a stock. So price I represents the price of the stock on ith day. You need to find the maximum profit that you can obtain by buying and selling the stock as many times you like. That means you can do multiple transactions. The way it is different from the first version of this problem is that you can buy and sell the stock multiple times. So let's say you buy the stock on day 2 at 1 and sell it on day 3 at 5, then you obtain the profit of 4. But now you can also buy the stock on day 4 at 3 and sell it on day 5 at 6 to obtain the profit of 3. So 4 plus 3 gives the total profit of 7. Is this the maximum profit we are looking for? We are going to find it out when we design its dynamic programming algorithm. But before that, I want you to subscribe to my channel and hit the bell icon, as that way you will get notified whenever I release new videos like these in the future. The array in question is over here, and beneath it I have created another array that is going to store the result of all the subproblems. The final cell of the array will give us the maximum profit we are looking for. If you have watched the previous videos of my dynamic programming tutorial, then intuition for this problem won't be a challenge, since this array is going to store the maximum profit of every subproblem. So I first put 0 in this cell, as the profit will be 0 on day 1. You agree, right? Now I'm going to solve this problem using my favorite 2 variables approach. It takes more time but is reliable. So I put variable I under the cell at index 1 and variable j under the cell at index 0. I'll give us the price at which we sell the stock, and j will be the buy price of the stock. For this subproblem, I gives 1 and j gives 7. So 1 minus 7 will give us minus 6. Would we anyway prefer taking a loss in the stock? No. So instead of minus 6, I would prefer populating 0 in this cell, which means I don't buy the stock at all. Now I moves one cell to the right. It represents 5 and j represents 7. 5 minus 7 gives me minus 2. But would I populate minus 2 in here or 0? I won't prefer the loss, so I populate 0 in this cell. In fact, why don't we skip the iteration where the selling price is less than the buying price? J moves one cell to the right. It now represents 1. Buying the stock at 1 and selling it at 5 will give me the profit as 4. Now one thing that you need to keep in mind is that this cell stores the profit obtained till here. We might have bought and sold the stock previously and obtained a profit that is stored here. Hence, we will have to add the profit that we achieved till here to the current profit that we obtained, which is 4. Why we are doing this? Because we can buy and sell the stock multiple times, which is why profit achieved till the last subproblem is important. Addition of 4 and 0 is 4, which is greater than 0 stored here. Hence, I populate 4 in this cell. Since j has completed all its iterations, hence I now moves to the next cell. I represents the selling price as 3 and j represents the buying price as 7. In this case, what will I populate? 0, because selling price is less than the buying price. J moves further and represents 1 as the buying price. This will give me the profit as 2, to which I will add the profit obtained till this subproblem, which is 0. So 2 plus 0 will give me 2, which is greater than the existing profit stored in this cell, that is 0. So I will store 2 in this cell. J comes to this cell now and represents 5. Again, selling price is less than the buying price. So the algorithm will love to skip this iteration. All the iterations of J are over. So I should move to the next cell. But before that, there is something that we need to observe. Check that the previous subproblem has 4 as the profit, which is greater than 2, which is the profit of the existing subproblem. We can buy on one day and sell on any subsequent day. So in the case of previous subproblem, we bought at 1 and sold it at 5. In this subproblem, we bought it at 1 and sold it at 3. Which one out of these two would you prefer? Obviously, the first case, because we are getting the profit as 4 in that subproblem. Hence, after all iterations are over, the algorithm will compare the result of the current subproblem with the result of the previous subproblem and will store the one which is greater. So in this cell, I store 4 because it is the maximum between 4 and 2. I didn't do this comparison in the previous iterations because I was waiting for the right scenario to appear. The algorithm will, however, do it for every iteration of I. Now let's move I to the next cell. I now represents 6. So 6 is the selling price. J has gone back to its base position and it represents 7, which is the buying price for now. Since selling price is less than the buying price, hence what we are going to do in this case, we will simply populate 0 in this cell. J will move one cell to the right. It now represents 1 as the buying price. I still represent 6 as the selling price. 1 subtracted from 6 is going to give us the profit as 5, which will be added to the profit calculated till here, till this subproblem. 5 plus 0 is going to give us 5, which is better than the value stored in here, which is 0. So in this case, 5 will replace 0. Now J is going to move one cell to the right. It represents 5 as the buying price and I represent 6 as the selling price. So 5 subtracted from 6 is going to give us 1 as the profit. Now this one will be added to this 4, which is the profit obtained till this subproblem, and it was obtained when we bought the stock at 1 and sold it at 5. So 1 added to 4 is going to give me 5, which is same as the value stored in here. So what I'll do, I'll simply eliminate this 5 and J will move one cell to the right. It now represents 3 as the buying price. 3 subtracted from 6 is going to give me 3 as the profit from this particular transaction. Now it will be added to this 4, which is the maximum profit obtained till this subproblem. And remember, we were having 2 till here. We compared it with the result of the previous subproblem and then we populated 4. So it is again the transaction result of buying the stock at 1 and selling it at 5. So 3 plus 4 is going to give me 7, which is better than this 5. So I am going to populate 7 in this cell. 5 will thus be replaced. Now since all the iterations of J are over, 7 will be compared with the value of the previous subproblem, which is 4. Between 7 and 4, 7 is the maximum. Hence the value remains unchanged. J goes back to its base position and I moves one cell to the right, to the final cell in fact. So I has moved to the last cell. It now represents 4 as the selling price and J has gone back to its base position and it represents 7 as the buying price. So in this case, selling price is less than the buying price. So we can either skip this iteration or can simply populate 0 in this cell. It's your choice. Now J moves to the next cell. and it represents 1 as the buying price. So 1 will be subtracted from 4 and it will give me 3. 3 will be added to this 0, which will again give me 3. 3 is better than this value stored over here, which is 0. So 0 is replaced by 3. Now J moves one cell to the right. It now represents 5. Here the buying price is greater than the selling price. So we can either skip this iteration like I told earlier, or what you can do, you can produce 0 in this iteration, compare it with the existing value in this cell. Since 0 is less than 3, hence it won't be able to replace this 3. So the iteration will still be skipped. J moves to the next cell and it now represents 3 as the buying price. So 3 subtracted from 4 is going to give me 1. Now this one will be added to this 4, which is the result or profit obtained till this problem. 4 added to 1 is going to give me 5. Now 5 is better than 3, right? So 5 will replace 3 in this case. J moves one cell to the right and it represents 6 as the buying price. Now selling price is less than buying price again, so we can skip this iteration. So after all the iterations of J are over, what we do, we compare the value of the current subproblem with the value of the previous subproblem. The value of the previous subproblem is 7, and between 7 and 5, which is maximum, 7 obviously. So 7 is going to replace 5. And we have the value populated in the final cell. 7 is the value and it represents the maximum profit that we can obtain when the array of prices given contains these prices. You will find a working Java solution of this problem in my GitHub repository, the link to which I have placed in the description box below. It has been tried and tested, it has already been submitted and it has been accepted well. With this, we have come to the end of this video. Let me know how you find this video. Let me know if you have any doubts in the comment section. I look so much forward to help you with programming and algorithms, and I hope you are enjoying my dynamic programming tutorial. Like this video, share this video, tell about my channel to your friends and family, to your colleagues. Help me reach a wider audience that impacts my ability to create videos like these in a direct manner. Until the next video, goodbye and take very good care of yourself.